Hello, my name is Thais. I am a PhD student at State University of Londrina, and I will present my master's study entitled Optical Characterization and Study of Internal Energy Transfer of LAPPS76 Terpolymer. LAPPS76 is a terpolymer. That means that it's formed by two copolymers. The copolymers are fluorine benzotiazole, Fb or L54, and fluorine terpyridine, Ft or L75. They were synthesized by Suzuki's polycondensation route in two different ratios, 30% of Ft and 70% of Fb, that we call L76-1, and the opposite called L76-2. The experiments were performed with the materials diluted in THF. Moving to the results, the first spectra are the absorption and photoluminescence of Ft. We can see that it absorbs between 340 and 370 nanometers, and has emission peaks at 309 and 410 nanometers. For Fb, we can observe that it has a large absorption spectrum with a peak at 450 nanometers, and the emission spectrum has a peak at 540 nanometers. We can see that the absorption of the terpolymer is a composition of the two copolymers' absorption spectra. For L76-1, the material absorbs more in the region between 375 and 500 nanometers because it has more Fb in its composition. The PL spectra, with extension at 355 nanometers, show that for L76-1 only Fb emits, which indicates energy transfer once we were exciting the Ft region of absorption. And for L76-2, we see that there is a saturation of energy transfer, and the Ft also emits. This can be explained by ET being internal to the molecule. When the states of Fb are all occupied, Ft will emit instead of travel to another molecule. This graphic shows a PL with intensity compared between the materials. With excitation at 350 nanometers, L75 Ft is the most intense, because it is its region of maximum absorption. But we can see that L54 Fb also emits, when excited in 350 nanometers. In the terpolymer, we see the energy transfer on L75-1 and energy transfer plus saturation for L75-2, that has a large emission of Fb that is only 30% of its composition. Moving to the emission decay time results, the results for the copolymer separated showed that the intensity average time of L54 is, in average, 2.5 greater than the L75, which can explain the saturation L76-2 terpolymer due to internal ET. For the terpolymer, the detection were made at 420 nanometers, region of ET emission, the donor. We can see that the amplitude average time for L76-1 is smaller than L76-2. This means that L76-1 transfers more energy, which agrees with what we're seeing on the PL spectrum. For the calculation of energy transfer efficiency, we use the amplitude average time for L75 in 10 to minus 6 milligrams per milliliter for the donor time in absence of the acceptor, and the amplitude average time of different concentrations of L76-1 and L76-2 for the donor time in the presence of the acceptor. The results showed that an average of 83% ETE for L76-1 and 44% of ETE for L76-2. To conclude, the obtained results show that there is energy transfer internal to the molecule from L75 to L54 in the terpolymers. It was observed that L76-2, that due to the lifetime of the excited state of L54 be 2.5 times bigger than the L76, and also the L54 to be in a smaller quantity, occurs the saturation of ET, which makes L75 also emits. The ET calculation through the emission decay time measurements showed itself coherent to the results obtained obtaining photoluminescence. In terms of OLED application, this study showed that L761 has a stronger emission in the region around 540 nanometers, which makes its application on a green LED promising. And L762 can be used as a blue and green emitter if the saturation of FB is controlled in a white emission blend in association with another polymer that emits red light. Acknowledgements, and thank you for your time. I will answer questions in the event in the Meet link.